In this video, we'll be covering the concave up or concave down of a rational function. Now, this rational function we've already worked with once before, so the first step is, again, always take the derivative, and then we have to do concavity, take the second derivative. So what I'm going to first identify is that in a previous video, we took the quotient rule of this function and then simplified it to end up with a function that was 4x squared plus 8x all divided by 4x plus 4 quantities squared. Now, with this information, I'm going to go ahead and apply the quotient rule one more time, because again, the most complicated part of these problems is taking the second derivative. So, very carefully, I'm going to apply the derivative rules. What is the derivative of the top function? That is going to be 8x plus 8. Again, that is the derivative of this function up top, times the bottom function unchanged. Now, right off the bat, this is going to look really nasty really quickly, but don't worry about it. It does simplify down quite consistently, almost always the same way. So it's the derivative of the top function, written, times the bottom function, unchanged, minus the derivative of the bottom function. Now, very carefully, I need to take the derivative of 4x plus 4 to the power of 2. Carrying down the 2, 4x plus 4 to the power of 1, and then don't forget your derivative of the inside. So the derivative of 4x plus 4 is 4. Then I'm going to go ahead and leave the second function left unchanged. So 4x squared plus 8x unchanged. This is all divided by the bottom function squared, which changes it to be a fourth power. Now, the piece that's most important to me in this example right here is the fact that this 4x plus 4 is actually existent in both of those terms, the top terms. When I say terms, I mean this whole thing here and this whole thing here. So the first step that I'm going to actually do to making this as simple as possible and as clear as possible is I'm going to factor out that 4x plus 4. So when I do that, this new first term becomes 8x plus 8 times the leftover 4x plus 4 minus, over here, since I factored that term out, it's going to be gone. I'm going to have 2 times 4, which is 8, and then we have 4x squared plus 8x left over. This is all divided by 4x plus 4 to the power of 4. Again, the most complicated part of this question is actually going to be simplifying this derivative. Now you'll notice, because this factor right here is being multiplied by everything inside, and this factor on the bottom has 4 of those terms, I can cross this one out. It's multiplication. This one I can't. I can't cross this one out because of that subtraction sign with it. But I can cross out the 4 and change it to a 3. That simplifies things down a little bit, not terribly so, but enough to make things worthwhile to handle afterwards. So this becomes now 8x plus 8 times 4x plus 4, which I can simplify that a little bit more, and I will, times 8, and then 4x squared plus 8x, all divided by this 4x plus 4 cubed. Now, my next step is I'm going to, again, try to simplify this as much as possible. Now, you're thinking off the bat is 8x times 4x, and we can do that. 8 times 4 is going to be 1632, and we can continue to do that work. But to me, I think that's going to be too much work. I'm lazy, and I want to avoid that. You'll notice in this factor right here, I can factor out an 8, leaving me with an x plus 1. In this one right here, I can factor out a 4, leaving me with another x plus 1. Now you'll notice in this original first term, there's an 8 and a 4. Over here, there's an 8, and out of these two terms, I can factor out a 4 and an x. Now, I don't think that x will be necessary, but I'm going to factor it out anyway so that we can see x plus 2. So now you'll notice, I have 8, I have a 4, I have an 8, I have a 4. And 8 times 4 is, again, 32, and I can factor 32 out of both this first term and this second term. When I do so, I'll have 32, and put brackets, x plus 1 times x plus 1. Again, 8 times 4 is 32, and then I have the 2x plus 1s left over. Minus the 8 and the 4 factored out to get me 32, and I'm going to have simply x times x plus 2. And now I don't know about you, but to me, this looks a heck of a lot easier to deal with in the grand scheme of the problem. So I'm going to go ahead and FOIL this out, which is nothing more than x squared plus 2x plus 2. I'm going to go ahead and distribute that back in, giving me x squared plus 2x. And then I'm going to very carefully note that that subtraction sign is still there. That subtraction sign will distribute to the x squared, canceling out those 2x squared terms. And the negative will cancel out to distribute to the 2x, which will cancel out those terms, leaving with nothing more than 64 over 4x plus 4 quantity cubed. Now again, you're thinking, is there any more that I have to do? And the answer is yes. But at this point, you have, again, where are your critical points? Where the second derivative does not exist or equals to 0. You'll notice if I try and set this top stuff equal to 0, we've simplified it so much to the point where this case doesn't happen. And all we need to do is where is the second derivative not existing? And that's where the bottom is equal to 0, which is going to be x equaling to -1 once again. I'm going to go ahead and check this such that I plug in -1 for my number line test between -infinity and -1 and -1 and infinity. Here, I'm going to have my test value, which is going to be -2 and 0. Here, I'm going to have what's my second derivative doing. At -2, when I plug in -2 down here, now keep in mind this is a cube, so it's no longer going to be positive every single time. 4 times -2 is a -8. -8 plus 4 is negative. Negative cubed is negative. The top is always positive. When I plug in 0, it's simply going to be 4 to the power of 3, which is positive. Top is always positive. Positive. So my original function f of x is now concave down and concave up. This provides me with enough information so that I can say we have concave up on the interval from -1 to infinity, and we have concave down on the interval from -infinity to -1.